Welcome to Hello Chemistry STPM channel. In this video, I'm going to talk about Markovnikov's rule. If you refer to Oxford Chemistry textbook, basically the definition of Markovnikov's rule is, in the addition of hydrogen halides such as hydrogen bromide or hydrogen chloride to an unsymmetrical alkenes, the hydrogen atom will attach itself to the carbon atom with a larger number of hydrogen atoms. As you can see here, this carbon number 2 and carbon number 3 is what we call as symmetrical alkenes because carbon number 2 and carbon number 3 have the same substituent, which is one hydrogen and one methyl group. As for this one, this is unsymmetrical alkenes because carbon number 2 and carbon number 3 had different substituents. And you have to know that Markovnikov's rule only applies to unsymmetrical alkene because if you react symmetrical alkene with a hydrogen bromide, for example, it will form the same product. So the keyword that you need to know in Markovnikov's rule is hydrogen will attach itself to the carbon atom with a larger number of hydrogen atoms, whereas for halogens such as bromine or chlorine, it will attach to carbon atom with the smaller number of hydrogen atoms. One example is when propane reacts with hydrogen bromide, as you can see here, carbon number 1 and carbon number 2, carbon number 1 have 2 hydrogen atoms, and then carbon number 2 have 1 hydrogen atom. According to Markovnikov's rule, hydrogen atom will attach itself to the carbon atom with a larger number of hydrogen atoms. So this hydrogen will attach to carbon number 1. As for the bromine, it will add to carbon number 2, since it has the smaller number of hydrogen atoms. The next example is propane react with hydrogen chloride. As you can see here, this is carbon number 1 and this is carbon number 2. Carbon number 1 is attached to 2 hydrogen atoms, and then carbon number 2 is attached to 1 hydrogen atom and 1 methyl group. So this hydrogen atom will added to carbon number 1 that have 2 hydrogen atoms, whereas chlorine atom will added to carbon number 2 and it will form 2 chloropropane as our major product. As for this one chloropropane is less likely to be formed. Another example is addition of hydrogen bromide to 2 methyl-propanes. As you can see here, this is the structure of 2 methyl-propanes, and this is carbon number 1, this is carbon number 2. Carbon number 1 is attached to 2 hydrogen atoms, whereas carbon number 2 is attached to 2 methyl group. So as I mentioned before, according to Markovnikov's rule, hydrogen atom will attach to carbon number 1 since it has the larger number of hydrogen atoms, and then it will form a tertiary carbocation. For your information, tertiary carbocation is the most stable as compared to secondary carbocation and primary carbocation. So the product form will be 2-bromol 2-methylpropane, and this is the major product. What happens when this hydrogen atom is added to carbon number 2? When this hydrogen atom is added to carbon number 2, it will form a primary carbocation. Primary carbocation is less stable as compared to tertiary carbocation, so the product is 1-bromol 2-methylpropanes, and this is less likely to be formed. This reaction is less favored. One thing that you need to know about Markovnikov's rule is carbocation are electron deficient group. That means carbocation can be stabilized by electron donating group, or we say electron releasing group such as methyl group. As you can see here, this carbon atom is attached to 3 methyl group, so it will form a tertiary carbocation, and this is the most stable one. This is the most stable carbocation. As for the secondary carbocation, this carbon atom is attached to 2 methyl group, and it is less stable as compared to tertiary carbocation. Primary carbocation is the least stable because it only has 1 methyl group attached to it. So that's all for Markovnikov's rule. Thank you.